Okay, good afternoon, everybody. Just in the last lectures or in the last week on the Saturday, we have gone through the filter circuit, definition of filter or concept of the filter, then applications of filter in the various field, as in the communication field or in electronic system designs, then the classification of the filters, that is the active filters and the passive filters, how to identify the active filters and the passive filters. Then we have turned toward the, say, fundamentals of the filters, that is the basic filters according to their operations, as a low pass operations, as a high pass, like the band pass and band stop operations. So as far as these fundamental operations is concerned, just we are going to see the what do you mean by the low pass filter, high pass filter, band pass, band stop filter, and what are the bands which are occurring in the low pass filter, that is the pass band and the stop band. Then how to say differentiate and how to define the what is the meaning of the pass band and what is the meaning of the stop band. Just we just seen in the last lecture. So today we are going to see the one by one, that is the low pass filters and the low pass filter. Just I will share my screen here. Okay, Shubham, is it visible for you? That screen is?
Yes, sir.
Okay, no problems. So just I would like to congratulate the Shubham and his partner and another two members. I forget their names. Just have prepared very fantastic the research articles. That means I have gone through this. That is a design and implementations of the DIS system. Okay, and second one is the design development of this. I think that say driverless car or the controls of the car, how to make the automatic controls of the car. So just I have gone to these two papers of this one. Just I have written very fantastic manner, just to have the need of their again, just to can review that research articles and the research papers, and just I can suggested some corrections in that papers, and just make the corrections according to this, and we can finalize these papers, and just we are going to represent these papers as a research papers in the college competitions. And before the 18th आजच मला वाटतं की काय 19th आज सांगितलंय का उद्याच्या लास्ट डेट सांगितलं and we are going to submit these papers. Okay, so this is all about. I would like to congratulate, and राहिलेले जे 6 जण आहेत, I don't know what are their names, तर थोडंसं मी घेतो मी आता पेपर हे झाल्यानंतर मी तुमचं थोडासा रिव्ह्यू घेतो त्याच्यामध्ये की कुणाचे आहेत काय नाही, आणि मग ते झाल्यानंतर आपण हे पाहूया. तर चांगले 5 पेपर्स आपल्याला आहेत. प्रत्येक पेपर्स मध्ये 2 विद्यार्थ्यांना 1 मिनिट त्याच्यामध्ये आपण दिलेला आहे. इट इज व्हेरी फंटास्टिक. तर त्या पद्धतीनं छान काम झालेलं आहे. I would like to congratulate all these students, that is 10 students for participate in the writing of the research paper and the presentation of the research paper. It is you are very lucky, I say that, just to have gone through this research paper at the time of when we are joined as a lecturer, and after the lectureship after 2 years I have joined as a research. तर तुम्ही इतक्या लवकर तुम्ही यामध्ये जॉईन फील्ड मध्ये झाला, इट इज चांगली गोष्ट, आणि कंटिन्यू तुम्ही ते करून ठेवणं गरजेचं आहे. ओके, व्हॉट एव्हर with these regards, just I will join to the filter, the next part of the filter, the second session for this unit number 3, that is filter from the BAT say 502, and already this is some fundamental parts just we have discussed in the last sessions in the last week on the Saturday. That means we have come up to this point, and just we have joined to this type of the filters, that is the low pass filters and the high pass filter is concerned. So we are going to see the first one is the low pass filter here. Again same problem. This low pass filter is concerned. So we can look at this left side, just to see a graphical representation or response of the filter. A response of the low pass filter, and just there is a response or a plot between the frequency against the gain of the low pass filters. So how to calculate the gain of the filter? This one. gain of the filter. So gain of the filter can be calculated by taking the different frequencies. This one. काय हे होत नाही एक मिनिट ठीक आहे ना की सिलेक्ट ऑप्शन से केलेला मला काय तर ते नाही येत नाही असं मला बाकीच येतं ना इंटरफेस होता म्हणजे काही तर काय आहे का
माऊसने एकदा स्टॉप करा परत येईल
काय टाकतो स्टॉप
आता इथं जाऊ माऊस
ना हे अनसिलेक्टेड
एरो ऑप्शन्स
बघितलं इथे रिटर्न म्हणू का
विजिबल
हां
विजिबल
नाही ना
एकदा प्रेझेंटेशन स्टॉप करा नंतर प्रेझेंट करा
ते बघितलं ना
बरं ठीक आहे करा प्रेझेंट आता आले का बघा हे राहू दे तिथं पॉइंटर आले बघा राईट क्लिक करा वर वर इथून घ्या वर वर ते हां इथून पण ना
तेच की हे तर काय झालं असणार
त्याचा काय विषय नाही सर हे काढून काय येते
हीच आहे ना
काहीतरी प्रॉब्लेम बघायला
का आपल्या ह्याला झाला का
लॅपटॉपवर
लॅपटॉपवर
त्याचा काय नाही प्रॉब्लेम
प्लेटचं नाही काय
स्लेटचं नाही तो पण घ्या थेरॉटिकल
चालतं ओके ओके लेट अस जॉइन दिस वन थोडासा लॅपटॉपचा प्रश्न आहे आपला त्या पेनला त्या स्लेटला आलेला थोडासा शुभ ओके हां तर let us join to this theoretical part again and tomorrow just will by making some corrections just will make some mathematical formulation related to the filter analysis for the low pass filter, high pass and band pass filters. So this picture is concerned or this graphical representation is concerned having a frequency against the gain. Already I have come to the point how to calculate the gain. So gain is nothing but this is the output signal to the input signal. It is called the gain of this filter circuit. Means a filter is nothing but it is electronic circuit having the input port is there and output port is there. Just we can apply the signal to the input ports and we can collect the signal at the output port. For the various frequency, you can take the data of the data at the output for the various frequency and we can try to calculate the gain of this output signal divided by input signal and just we can make the relationship, plot the relationship between the say frequency against the gain of this one and just you can find that at the low frequency side this one this is a zero, this is the frequency side, okay, this is the gain side and just at zero frequency the gain is maximum at the low pass filter is concerned. And we are going increasing the frequency up to this point. The gain is constant, and afterwards the gain will be immediately drop. The gain will immediately drop to zero. That means they have a cutoff frequency. Means the gain is automatically dropped to zero at a frequency. That frequency is known as a cutoff frequency, and beyond this cutoff frequency, the gain of the filter circuit is zero. You can try to see this. You can go on increasing at this frequency, the gain is zero. But at this frequency, the gain is maximum. At this frequency, gain is maximum. At cutoff frequency, the gain is maximum. But there is a sharp cutoff. This one for the ideal filter circuit is concerned, the gain will be decreases to directly to zero at cutoff frequency. Okay, and afterwards, we go on increasing the frequency at the highest frequency side, the gain will be zero. That means we can look at these pictures. We observe that at from 0 to FC, at 0 to FC, within that frequency band, within the range of frequency, the gain is constant. The gain of the filter is constant. That is, the A0 is constant. And that gain is sufficient gain to transmit the signal from source point to the destination point so that that range of frequency, the band of frequency is known as a pass band. So this is nothing but the pass band starts from 0 to FC and within that frequency, the gain is maximum and the signal will be transmitted with the full gain from source to destination. and that range of frequency or the band of frequency is known as a passband. Similarly, at the frequency FC or the beyond the frequency FC, म्हणजे FC नंतरच्या frequency at higher frequency, the gain will be 0. For the ideal filter is concerned, means there is no transmission of the signal from above the frequency FC. That band of frequency is known as a stop band. So we can try to understand what we mean by the pass band and what do we mean by the stop band. Since the pass band as well as the stop band, they may be occurred in the low pass filter, high pass filter, band pass filter, band stop filter, and in some of the filter, some filters have the one pass band, the one stop band, and two pass band, and the one stop band, two stop band, and the one pass band, whatever may be this one. So that's why we are going to understand what is a concept of the pass band and the stop band, and we can going to see how many pass band and stop band in each type of the filter. So this is the thing, but they have the one pass band and the one stop band. Means the pass band starts from 0 to FC, and the stop band starts from FC, that is cutoff frequency, to F is equal to F infinity. F is equal to infinity. FC is equal to this cutoff frequency. F equal to FC to F equal to F infinity. That range of frequency, that band of frequency is a stop band. Means as the low pass filter is concerned, which have the one pass band and the one stop band. So we can try to understand the function of the low pass filter. Means low pass filter is a filter which can pass the band of the low pass frequency and cut off or attenuate or the block or stop or the prevent the band of the high frequency. And therefore that response, that filter is known as a low pass filter. That means the name itself suggests that the circuit which can pass the band of the low frequency and stop the band of high frequency. So that it is known as a low pass filter which have a one pass band, and the one stop band. So this is all about the low pass filter is the one, and we can look at this one. What we observe here, we should observe here, there are two types of responses there. The first response is that means we are going increasing the frequency from F equal to 0 as gain will becomes constant, and at frequency F equal to FC there is a sharp transition, that is sharp frequency transition, within which the output of the filter will be drops from high level to the low level. It immediately drops to the 0, means the output power is 0. And after this frequency or beyond this frequency, the output power is 0, and there is no transmission of the signal from F equal to FC to F equal to infinity. That is known as stop band. Means the higher frequency are rejected and the lower frequencies are allowed to pass from source point to the destination point, so that the filter is known as a low pass filter. Again, the low pass filter is concerned, it have a cutoff frequency denoted by the F equal to FC. C means cutoff frequency, and this nothing but sometimes it is known as the FH frequency. त्याला काय म्हणतात, त्याला FH म्हणतात. FC च्या ऐवजी सुद्धा FH. What is the F? It is here. What is the H? What is H? What is H means काय? H म्हणजे काय? H nothing but higher cutoff frequency. म्हणजे low pass filter is concerned which have a higher cutoff frequency. म्हणजे याला कशी येते? Higher cutoff frequency. It is called the higher cutoff frequency. It means the band of frequency from 0 to FC will be transmitted, that is called the pass band, and the band of frequency from FC, F equal to FC to F equal to infinity, that band is known as a stop band. It is known as a stop band mantat, or it is called the rejected band. It is mantat. So similarly, you can look at this one, the second figure or second graph. What we observe that there is again the graphical representation between the F equal to against the frequency F against the gain A0. You can see that as frequency increases, the gain of this filter circuit increases. Okay, gain of the filter circuit increases. After a certain frequency, the gain will remains constant. So this is nothing but this is the response of the high pass filter. This is the graphical representation or graphical response of the low pass filter, and this is the graphical representation or graphical response of the high pass filter. What will happen in the high pass filter? What is high pass filter? So high pass filter is a filter in which high frequency band of frequency should be transmitted without any attenuations, and the low band of low frequency should be attenuated, or that band will be not allowed to go from the a source point to the a destination point. So this is the concept. This is a distinguish between the low pass filter and the high pass filter. Means high pass filter pass the band of high frequency and low pass filter pass the band of the low frequency. So that the high pass filter is concerned, these are the you can look at this one. There are two responses. This one is ideal response. What we observe the ideal response during that frequency, low frequency from 0 to FC, the output is 0, and from at frequency F equal to FC, there is a immediate sudden a transition between the output from it will be launched from 0 to say A0. Okay, the gain will be increased from immediately in the instant 0 to becomes A0, and afterwards the gain will be remains constant. Means again this is ideal response. This one dotted line is the ideal response, and whatever this one we can observe a second response. That means the as frequency increases, gain will be linear increases, and after certain frequency, say the gain from this frequency, the gain will be likely to be remains constant. So this is known as a practical response of the high pass filter. High pass filter a practical response. Again we see that here. Again, the high pass filter have two bands, that is the stop band and the pass band. Means the high pass filter contains the one stop band and one pass band, and its stop band starts from say 0 to FC, and pass band starts from say FL म्हटलेलं आहे FC किंवा it is known as FL, it is for the lower cutoff frequency from FL to F equal to infinity. म्हणजेच just we can mention the range of the stop band and the pass band related to the high pass filter. So as the high pass filter is concerned, it have two band, stop band and the pass band. Stop band starts from 0 to FL, and the pass band starts from FL to F equal to infinity. So this is all about the high pass filter. Means the high pass filter is concerned which have two bands, stop band and the pass band, in which the band of the high frequency will be transmitted from source to destination without any alternation. That band is known as high frequency band, starts from F equal to FL and goes to the F equal to F infinity, and stop band has the range from F equal to 0 to F equal to FL. So FL is known as the another name lower cutoff frequency. F is a frequency, suffix L is known as the lower cutoff frequency. So as far as the high frequency is concerned, it have a cutoff frequency, and that cutoff frequency is known as a lower cutoff frequency. As the low pass filter is concerned, it have a cutoff frequency, and that cutoff frequency is known as a higher cutoff frequency denoted by FH. म्हणजे लो पास साठी FH ने डिनोट केली जाते आणि हाय पास साठी FL ने डिनोट केली जाते. So this is about the two types of the fundamental filter, that is low pass and the high pass filter. Then we should join to the next two types of filter. The first one, that is third one, means we can look at this one, the third graphical representations, and that is nothing but it is the band pass filter. But I'm saying that this is band pass filter. Just this, we can look at this response, and that response will be nothing but relation between the frequency and this gain of the filter circuit. We can find that as frequency increases, gain increases, it will remains constant, and after a certain frequency, the gain will go on decreasing. What is this? This is nothing but this is the frequency response of the series circuit. काय म्हणतो मी त्याला series circuitचा response आहे. Series circuit कुठला आलं? The circuit which is formed by resistor, capacitor and inductor, that is called a series circuit. And just you can take the data for the different value of resistance. We can note down the frequency against the gain, and we can plot the response this, and we can find that this is nothing but the downward parabola is there. असा दिसतो तुम्हाला कसं दिसतोय? It is nothing but it is the shape of this curve it is similar to the downward parabola in mathematics. The parabola शब्द कधी ऐकला असेल तुम्ही? Hyperbola, parabola, ellipse, circle. तर त्याच्यामध्ये पॅराबोलाचे टाइप्स आहेत. दिस इज कॉल्ड द डाउनवर्ड पॅराबोला, इट इज कॉल्ड द अपवर्ड त्यानंतर राईट हँडेड पॅराबोला आहे, लेफ्ट हँडेड पॅराबोला आहे. तर अशा पद्धतीचं पॅराबोलाचे टाइप त्याच्यामध्ये आहे. त्याचे हायवेगळे टाइप ऑफ द कोनिक सेक्शन्स त्याच्यामध्ये. तर दिस इज नथिंग बट दिस रिस्पॉन्स ऑफ द series resonance circuit for the RLC circuit is concerned. And just we can look at this one, and this is nothing but this is the response of the high pass filter. We are going to define what is our objective. Our objective is to try to understand. We are knowing that what do you mean by the band pass filter. So the band pass filter is concerned in which the band pass filter will be allowed a certain band of frequency. That may be lower side, that may be higher side, that may be at the middle side. That means the band pass filter is a filter which can pass a certain band of frequency, certain range of frequency without attenuations and block. What I'm saying that it should block a band of frequency at the lower side or as well as at the higher side. That means the high pass filter is concerned, sorry, band pass filter is concerned, it have a one pass band and two stop bands. दोन तुम्हाला दिसतात बघा. कॅन लुक ॲट दिस पिक्चर्स. त्यामध्ये दिसल्यानंतर तुम्हाला काय दिसतंय, त्याच्यामध्ये तीन बँड दिसतात. एक पास बँड दिसतोय ॲट द मिडल, वन स्टॉप बँड ॲट द लोअर साइड दिसतोय, अँड नेक्स्ट इज जस्ट यू कॅन ऑब्झर्व द वन मोर स्टॉप बँड ॲट द हायर फ्रिक्वेन्सी साइड. हायर फ्रिक्वेन्सी साइडला तुम्हाला तो बँड त्याच्यामध्ये दिसतो. त्याच्यामध्ये तर याच्यामध्ये तुम्ही पाहिलं तर काय इथे आहे बघा, फ्रिक्वेन्सी वाढली, ओके, the gain increases, remains constant, it will drops, okay, and at one particular frequency the gain is maximum or the current is maximum or the power is maximum. What I'm saying that the circuit is more active or the circuit is more resistive. What I'm saying that the circuit is more resistive, that inductive and the capacitive effect goes cancel to each other and the circuit will behave as a resistive, and that's why there is a less opposition. That's why we can observe the maximum current in the circuit, and due to the maximum current there is a maximum power, and due to this maximum power we can find the maximum gain, so that at frequency that is f equal to f0 the gain is maximum. आता एखाद्या असं म्हणू शकतो की why the gain is maximum. हा रिस्पॉन्स कसा दिसतो तुम्हाला, फ्रिक्वेन्सी वाढले की काय होतं, गेन वाढत जातोय, म्हणजे करंट वाढतोय, पॉवर वाढते. ॲट वन फ्रिक्वेन्सी द पॉवर इज मॅक्सिमम, करंट इज मॅक्सिमम, ओके, अँड आफ्टर दी बियॉन्ड दॅट फ्रिक्वेन्सी gone increasing this, again the current will be decreases. What does this mean? Means at this frequency the circuit will be behaved as a resistive. There is a less oppositions. Due to this maximum current will be flowing to circuit, there is a maximum power is there, and due to this there is a maximum gain is observed, so that at frequency f equal to f0 the gain is maximum, current is maximum, power is maximum. That frequency is known as a resonant frequency. What I'm saying that this is known as a resonant frequency. And to the left side there is another frequency that is known as say FL frequency, and the higher side there is another frequency that is known as FH frequency. Means on this frequency axis we can look at this, there are three frequency, f equal to f0 there is known as a resonant frequency, f equal to FL and f equal to f0. Again there are two frequencies at the lower side as well as the higher side. These two frequencies are as a 3 dB frequency or cutoff frequency of the response, lower cut of the frequency. म्हणजे समजा हा गेन तुमचा A0 and if this gain is in decibel असेल, and suppose that the gain is 70 decibel असेल, किती असेल 70 decibel समजा 70, and we can subtract the 3 decibel from the 70. म्हणजे 70 वरनं 3 decibel वजा केलं, राहिले किती 67. मग ह्या हा मॅक्सिमम पॉईंट 70 असेल आणि इथं खाली जर तुम्ही घेतला तर इथे किती येतो 67 येतो, आणि 67 आला की तिथून काय करायची, वी कॅन ड्रॉ ए हॉरिझॉन्टल लाईन और पॅरलल लाईन टू द फ्रिक्वेन्सी ऍक्सिस, अँड दॅट लाईन विल बी कट इन द 2 points टू दिस कर्व. या कर्वला 2 पॉइंट मध्ये कट करते, इथे कट केलेले आहे आणि इथे कट केलेले आहे, and ज्या पॉइंटला कट करते the line cut at this point, that at that frequency is known as a lower 3 dB frequency. म्हणजे ह्याला म्हणायचं की लोअर 3 dB का म्हणतात, तर ही लो फ्रिक्वेन्सी साइडला आहे म्हणून that FL is known as a lower 3 dB frequency, and that at this side, okay, that frequency is a upper 3 dB frequency. अप्पर साइडला म्हणजे हायर फ्रिक्वेन्सी साइडला आहे म्हणून त्याला अप्पर फ्रिक्वेन्सी म्हणतात. 3 dB का म्हणतात की 3 dB याचा अर्थ काय होतो 3 डेसिबल. 3 dB means 3 decibel. Suppose our gain is a 70 decibel, and we are subtracting the 3 decibel gain from this. We are getting the 67. From the 67 gain, we can draw a parallel line to the frequency axis, and that will be cut in the 2 points. And 2 points la cut karte. And cut केल्यानंतर we can forward or extend the perpendicular lines on the frequency axis. Similarly, this at the lower side there is a we are getting the one frequency at the lower side, that is known as a lower cutoff frequency, or sometimes known as a lower 3 dB frequency. Similarly, we can extend a line from that cutoff frequency on the x-axis. We are getting the another frequency known as a higher cutoff frequency. So that another name is that higher cutoff frequency known as a upper 3 dB frequency. So just we are getting the two frequency as a lower frequency side and the higher frequency side, namely as lower 3 dB cutoff frequency and upper 3 dB cutoff frequency, named as FL and FH. And the difference between these cutoff frequencies, suppose that this is at the 100 kilohertz, okay, this is at the 50 kilohertz, and this is at the 10 kilohertz. So this is 100 minus 10 kilohertz. That is means that difference is a FH minus FL. That is a 19 kilohertz frequency band will be transmitted without any attenuation. And the band of frequency below from that is a FL to 0, means from 0 hertz to 10 kilohertz, that band of frequency has been rejected. That band of frequency does not allow to transmit from the source to destination. Similarly, the band of frequency above FH, means above the frequency above 100 kilohertz to infinity, that band of frequency never allowed for the transmissions from source to destination. So this is the another type of the band, another stop band. Means as far as the band pass filter is concerned, which have a one pass band and the two stop band, the pass band range starts from FL to FH. It is a one pass band. Similarly, it have a two stop band. The stop band starts from F equal to 0 to F equal to FL, and the second stop band starts from F equal to FH is equal to F equal to infinity. When just F0 to N infinity, it is a one stop band. F equal to 0 to FL, this is another stop band. That means the band pass filter have a two stop band and the one pass band, that is pass band starts from FL to. So this is all about this the response and the pass band and the stop band, which will be occurs in the band pass filters, and this is the theory behind this one. And in all, just I would like to conclude that the band pass filter is filter. It can pass a certain range of frequency, certain band of frequency, and alternates a certain band of frequency at the lower side and certain band of frequency at the higher side, so that that frequency, that filter is known as a band pass filter. And we can try to remember that the band pass filter have a two stop band and the one pass band, and it can pass the band of frequency and stop the lower and high frequency. Similarly, on the same line of actions, we are going to say see or the focus or the define the band pass filter. And the band pass filter is nothing but it is exactly replications of the band pass filter. Means band pass filter have the downward parabola, the shape of this one, and as far the band stop filter is concerned, it have the upward parabola. Asa kasa to upward parabola. Exactly opposite that of the band pass filter. In the band stop filter, again it have a response that is nothing but that's the response of the parallel resonance circuit. तो कोणाचा आहे तुम्ही पाहिला असेल सर्किट कधी. The parallel resonance circuit, and parallel resonance circuit मध्ये काय असतं, at frequency f equal to 0 there is maximum gain is there, output signal is there, then frequency increases, the gain will be decreases. At low frequency the gain will become 0, and it will go on increasing the frequency, the gain will be increases, and the frequency at which the gain will be 0, that is known as the anti-resonant frequency. त्याला काय म्हणतात, anti-resonant frequency. म्हणून आपण या हाय पास बँड पास फिल्टरला आपण म्हणतात the acceptor circuit म्हणतात, and बँड स्टॉप फिल्टरला रिजेक्टर सर्किट म्हणतात. बँड पास फिल्टरला काय म्हणतात, the acceptor, why it is called the acceptor circuit, since at this frequency, at resonant frequency, all signal will be transmitted without any attenuation. That means it can accept all the data, so that is known as acceptor circuit, and the gain is maximum, current is maximum, so that circuit is an acceptor circuit. But while the at anti-resonant frequency, in case of the non-stop filter, the gain is 0, and at that band of frequency, all data will be rejected. So it is known as a what type of circuit? Rejector circuit. Means within that band of frequency, all frequencies, all data, all intelligence have been rejected. So that type of band is also known as a stop band. Which exactly opposite that of the band pass filter. So band stop filter is concerned, again, similar to that of the band pass filter, it have two bands, but it contains a two pass band and one stop band. Means band stop filter is allowed to pass a certain band of frequency. Within that band means the frequency between the FL, that is lower cutoff frequency, and the frequency between the higher cutoff frequency FH, and frequency within that range of frequency has been attenuated. That data, that signal does not transmission from the source to the destinations in the circuit. So that band of frequency is known as a stop band, and having a central frequency that is known as a F0, and that frequency is known as a anti-resonant frequency. At this frequency, all components have been rejected, so that is called as a rejector circuit. But the band of frequency below FL, that is at the lower side band, and as well as at the upper side band, that is the band of frequency above the FH, that band will be transmitted. Means the band of frequency from F equal to F0 to F equal to FL, that band of frequency will be passed without any attenuations. And similarly, the band of frequency from F equal to FH to F equal to F0, that band of frequency will be transmitted without attenuations. Means it have two bands, that is a two pass band, that is the one band at the lower side, that is one pass band, and another band on the higher frequency side, that is another type of the pass band. That means pass band occurs at the low frequency side and the high frequency side, and the stop band will be observed at the middle frequency, and that will be rejected. So that just I will try to conclude, I try to compare between the band pass filters and band stop filter. Band pass filter, it have a two stop band and the one pass band. Similarly, the band stop filter have a two pass band and the one stop band, and the band pass filter is also called as a acceptor circuit, and band stop filter is called the rejected circuit. And so that just I have, again you can observe that at the band pass filter as well as the band stop filter, there are just I have FL पुन्हा dotted line ने केलेला आहे, परत इकडे आलेला आहे, परत from this frequency the gain will be dropped to 0. म्हणजेच हा तुमचा काय झाला, परफेक्टली रेक्टँग्युलर झाला. म्हणजे it is nothing but it is the ideal response of the band pass filter, and this is nothing but it's a curve section. It is nothing but a practical response of the band pass filter. Similarly, at this one is concerned, this is again the dotted line observed at frequency 0 is equal to maximum gain, and that frequency at the lower side F equal to FH, the gain will be dropped from the higher to lower. Okay, again the gain will be 0, and again at certain frequency F equal to FH, again there is a sudden transition of the gain from 0 to the maximum, and it will remains constant. That means this dotted line, the representation is nothing but the ideal response of the band stop filter, and this is a curve sections. That is a F equal to 0, there is a maximum, and it will go on decreasing, become 0, and again the frequency increases, again increases, so that this response is nothing but this is a practical response of the band stop filter. That means again in each diagram of the band pass filter as well as the band stop filter, we observe the two types of the responses, that is ideal response and the practical response. So this is all about the low pass band pass filter and the band stop filter and their comparison. Next, we have to join to the next type of filter, that is the last fundamental filter. So that filter is known as all pass filter. There is a, we can look at this one. This is the response of the all pass filter. Originally, the first response is at a transmitting end. So in the all pass filter, and all pass filter are the electronic circuit, or it is electronic filter in which the all frequency components, all data will be transmitted from the source to destinations. जिथे आपण टेलिफोन लाइन मधून आपण डेटा पाठवतो from source to destination, that signal will be transmitted over a telephone line from source to destination. All frequency data will be transmitted from the source to destinations without changing the amplitude. But amplitude because this is a constant distance. But there is a we can observe the change in phase. There is a phase difference between the transmitting and receiving end. We can measure the phase difference at the transmitting end and the receiving end, and we can compare this phase difference. We observe that there is a certain phase difference or the lagging between the transmitting signal and the receiving signal. That difference is known as the phi. So this is only limitations of this say all pass filter. Means all pass filter is a filter which can transmit all frequencies in all times without changing its amplitude from transmitting to receiving it. So can you look at this one? This is the original signal, starts from 0. 0. This is the original signal transmitted from the transmitting end, and similarly this is another signal we have received, recovered at the receiving end, and इथं आपण उशिरा थोडीशी आपण काय केलेली आहे ती रिकव्हर केलेली आहे अशा पद्धतीने दिसते. And we can observe that there is a fair difference between this transmitting and that is the phi. So this is the only limitation of the all pass filter, and in order to correct the phase difference तर ह्याच्यासाठी आपण त्या ऑल पास फिल्टरचा किंवा फेज करेक्टर सर्किटचा सुद्धा वापर आपण त्या ओव्हर ट्रान्समिशन कम्युनिकेशन सिस्टीम मध्ये करू शकतो. सो दिस इज ऑल अबाउट द फंडामेंटल फिल्टर्स, that is a low pass filter, high pass filter, band pass filter, band stop filter, all pass filter, and just we have studied all the type of this filter with respect to their response, that is ideal response, practical response, pass band, stop band, and the concept or the working mechanism of this all type of the low pass and high pass and band pass filters. So just we are going to join to the next type of filter, that is nothing but the Butterworth and the Chauvel filters. And already in the last sessions in the Saturday, just I have mentioned that there are some other type of filters rather than the fundamental filters, that is a low pass, high pass, band pass and band stop filters. And again there are some type of filter, that is a Butterworth filter, Chauvel filters, response filters. हे काही फिल्टर्स त्याच्यामध्ये आपण त्याच्यामध्ये आहे त्याच्यामध्ये. तर दॅट मीन्स दॅट फिल्टर्स हॅव बीन स्पेशली डिझाइन्ड बाय द सायंटिस्ट, दॅट इज बटरवर्थ and scientist Chauvel. They have worked research works on this filter to design the various types of filter of different types in order to try to minimize the transaction frequency or try to say minimize the gain roll off. But I'm saying that gain roll off म्हणतो, gain roll on म्हणत नाही. gain roll off म्हणजे याचा अर्थ काय होतो की आपण just we are measuring the gain roll on or roll off. In case of the frequency response of the operational amplifier, the gain roll off or gain roll off should be measured in terms of the decibel. That is the as far as the gain roll on gain roll off is concerned, operational amplifier is concerned, its measure is at 20 decibel per decade. हे काय म्हटलं की ऑपरेशनल एम्प्लिफायरचा आपण रिस्पॉन्स पाहिला आणि त्याचा गेन रोल ऑन बघितला किंवा रोल ऑफ बघितला आपण. त्याच्यामध्ये रोल ऑफ म्हणजे डाऊनवर्ड असं म्हणत, म्हणजे फ्रिक्वेन्सी वाढली ऍक्सेलरेटर फ्रिक्वेन्सी पासून गेन काय होतो, गेन काय होतो, कमी होतो. याच्यामध्ये गेन काय होतो, असा कमी होतो, कमी 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 होतो. आणि हा कसा कमी होतो, किती डेसिबलला कमी होतो, तर ते आपण ऑपरेशन एम्प्लिफायर मध्ये जर पाहिलं तर द गेन रोल विल डिक्रीजेस विथ द रेट ऑफ 20 डेसिबल पर डेकेड. व्हॉट डू मीन बाय डेसिबल पर डेकेड? तर आता आपण इथे घेतलं, आपण समजा ही फ्रिक्वेन्सी एफ इक्वल टू कट ऑफ फ्रिक्वेन्सी आहे से एफ एच आहे आणि ही 10 किलोहर्ट्ज आहे. आणि त्याच्यानंतर इथे मी दुसरी फ्रिक्वेन्सी इथे घेतली, इथे घेतली एफ इक्वल टू एफ एच, दुसरी फ्रिक्वेन्सी घेतली, ती फ्रिक्वेन्सी 100 आहे, म्हणजे हे 10 आहे आणि ते 100 आहे. तर 10K आणि 100K म्हणजे 10 टाइम्स फ्रिक्वेन्सी घेतली आणि 10K ला घेतला गेन मी बघितला, इट इज मॅक्सिमम आहे समजा, बरोबर आहे. इट इज से 40 आहे आणि दुसरी जी फ्रिक्वेन्सी 100K आहे त्याचा गेन किती आहे, याचा गेन जो आहे तो किती आहे, 80 आहे. आता 100 मायनस 80 गेन मधला फरक किती झाला, 20 झाला आणि फ्रिक्वेन्सी मधला बदल किती झाला, 10 टाइम्स झाला. म्हणून 10 टाइम्स फ्रिक्वेन्सी बदलली तर गेन कितीने कमी होतो, 20 ने होतो. म्हणून इन ऑल दॅट शुड बी say written as the gain decrease of the gain 10 time decrease of gain should be 20 decibel per decade. म्हणजेच 20 decibel per decade gain, decrease in the gain represents that this is a decrease in the gain. The frequency will be increases from 10 times increase, 10 times increase, 10 times increase, so the frequency increases from say 10 kilo to 100 kilohertz. When the frequency will be increases from 10 times, the gain will be decreased as the 20 decibel, so that unit is known as a 20 decibel per decade. So this is the gain rule of this one. So my point is to say that just we are going to study the some Butterworth filter and the Cheoba filters. So Butterworth is nothing but it's the name of scientists. He have designed and discovered a new type of filter that is known as specifically the Butterworth designed the low pass filter for the various order of filter, and he has done his experiment several number of times in can try to say increase or decrease. असं म्हणता येईल की आपल्याला there is a sharp transition of the constant in the passband. Passband मध्ये gain कसा constant राहील and there is a sharp transition of frequency कसं होईल by increasing the order हे त्याने स्टडी केलेलं आहे. म्हणजेच Butterworth the filter is a special type of filter designed developed by the this one is nothing but the first band on the side la low frequency side. A low frequency side la पाहिलं तर it is known as a pass band, and in the higher side frequency there is from 0 to fh, and stop band starts from fh to f equal to infinity. म्हणजेच Butterworth filter design and develop the case of the low pass filter for the various order म्हणजे order of filter, the first order, second order filter. The order of the filter depends upon the number of RC combination. त्याच्यामध्ये फिल्टरचे R and C combination किती आहेत त्याच्यावरनं तुम्ही जर एकच कॉम्बिनेशन वापरलं R and C चं, it becomes a first order, आणि तुम्ही दुसरं कॉम्बिनेशन वापरलं, दोन कॉम्बिनेशन RC वापरली तर सेकंड ऑर्डर फिल्टर. म्हणजे असं जर तुम्ही RC कॉम्बिनेशन ऑर्डर केला तर ऑर्डर ऑफ फिल्टर विल बी इंक्रीजेस. आता असे नंबर ऑफ सर्किट डिझाईन केले, डेटा घेतला, प्लॉट केला, रिस्पॉन्स घेतला, आणि त्याच्या असं लक्षात आलं की ऑर्डर ऑफ फिल्टर म्हणजे ही जस्ट पहिले जी आहे ती n इक्वल टू 2च आहे. पुन्हा हे दुसरं n इक्वल टू हा रिस्पॉन्स आहे n इक्वल टू 4च आहे, ही n इक्वल टू 6च आहे. म्हणजे असं जर ऑर्डर ऑफ फिल्टर वाढवत गेला तर काय झालं, तुमच्याकडे काय लक्षात येतंय, फ्रिक्वेन्सी वाढली तर काय होतं, गेन ऑलमोस्ट कॉन्स्टंट होतो आणि देयर इज अ शार्प ट्रान्झॅक्शन होतं. म्हणजे द फ्रिक्वेन्सी ॲट विच द गेन विल ड्रॉज फ्रॉम हाय लेवल टू द इमिजिएटली टू झिरो लेवल. आपला म्हणजे ते शुड बी शार्प ट्रान्झॅक्शन. म्हणजे जी कट ऑफ फ्रिक्वेन्सी येते ती कट ऑफ फ्रिक्वेन्सी आल्याबरोबर गेन काय झाला पाहिजे, झिरो झाला पाहिजे. म्हणजे फ्रिक्वेन्सी किंवा तो डेटा काय झाला पाहिजे, ब्लॉक झाला पाहिजे. हा त्यातला एक टार्गेट त्याच्यामधला. आणि ही फाउंड दॅट ॲज ऑर्डर ऑफ फ्रिक्वेन्सी इन्क्रीजेस, ओके, there is a sharp transition of the cutoff frequency, sharp transition of the cutoff frequency. म्हणजे जेवढे ऑर्डर ऑफ फिल्टर वाढवत जाईल तेवढा तुमचा गेन कॉन्स्टंट राहिला, आणि there is a sharp transition of cutoff frequency म्हणजे equal to fh, and we are getting the perfect pass band या याच्यामध्ये and perfect the stop band. म्हणजे there is a sharp pass band, the sharp the cutoff band, and both pass band and the stop band have a sharp cutoff frequency, and sometimes they are equal, so that means the पास बँड किंवा स्टॉप बँड म्हणतात त्याला, असं या पद्धतीने याच्यामध्ये म्हणतात. आणि दिस इज अनदर रिस्पॉन्स फॉर द Butterworth filter, that is the nothing but graph between the say that the angle against the phase difference याच्यामधला तुम्ही किंवा ऑर्डर ऑफ द फिल्टर असं आपण म्हणूया. दिस इज ऑर्डर ऑफ फिल्टर, दिस इज द फ्रिक्वेन्सी अगेन्स्ट द से फेज डिफरन्स म्हणजे 0 पाय 180 2 पाय 360 का असेल ते. दिस इज द नथिंग बट फेज डिफरन्स बिटवीन द इनपुट अँड आउटपुट याच्यामधला. दॅट इज ऑर्डर ऑफ फिल्टर n इक्वल टू 2 आहे. This one, you can observe that as the order of filter will increases, there is increase in the linear increase the phase difference. असं तुम्हाला तुमच्यामध्ये linearly increase दिसतं. असं लक्षात ठेवा, linear increase दिसतं त्याच्यामध्ये. So this is all about the Butterworth filters, आणि ह्या लो फ्रिक्वेन्सी ऍप्लिकेशन साठी या Butterworth filterचा वापर केला जातो. Okay, so this is all about the various types of fundamental filters. Just I take the review of this sessions. Today we have seen the types of filter, that is fundamental filter, low pass filter, high pass filter, band pass filter, band stop and all pass filters. Their frequency response, that is ideal response, practical response, various types of pass band, what is the range of the pass band and the stop band, and their working mechanism and the functions. And just finally we have touched to the new type of filter, that is a Butterworth filters designed by the scientist Butterworth and implemented for the low frequency applications for the high order of the filters. तर त्याच्यामध्ये आपण पाहिलं त्याच्यामध्ये आहे. तर we'll just here the just I will conclude this my sessions, and we come to the front side, that is the this one.